The hierarchical clustering has a well-written algorithm in SciPy library, which we will be using during this video. Here you can see how we easily import the important and required libraries. And you can see that we have imported dendrogram and linkage for the hierarchical clustering using the SciPy library. Here in this part of the code, we have generated 10 random sample points, which is shown in the scatter plot. We have also given each point one separate label. Since at the beginning we consider each point in a separate cluster, this example would be of an agglomerative clustering type. Here you can see how we have imported 10 different sample data points, and this for loop is written here in order to show the scatter plot, and the labels are given to each one of the points separately at the beginning. The scatter plot of the data points is shown in here. In this part of the code, we have determined the linkage type to be set to single linkage and plotted the dendrogram of the single linkage hierarchical clustering, as you can see here and here, by using the dendrogram that we have already imported from the SciPy library. And this is the dendrogram. If you want to have a specific number of clusters like 4 in here in this example, we can easily import and use the agglomerative clustering from scikit-learn library. As you can see here, we have set the number of the clusters to be equal to 4 in here. The cluster numbers can be reached by using the fit predict function. This is the scatter plot of the cluster data. The data was clustered into 4 different groups using the single linkage method. So let's solve a more real problem. We will load a data set that has 2 properties of the shoppers: annual income and the spending score. In order to load the CSV file, we need to use the pandas library, which is already imported. Since we want to upload the external files stored on the Google Docs or on the local machine, we need to import the files from the Google Colab. We must use the pandas function read CSV. Here you can see the samples with 2 features, annual income and the spending score, here in the results. So we would get like 200 different samples that have 2 different features, annual income and the spending score. Then we will repeat the same routine to show the dendrogram of the data using single linkage and also ward method, which are shown in here in this part. It must be noted that in ward agglomerative clustering, clusters are merged at each stage based on the optimal value of an objective function. In general, the objective function would be the error sum of squares. Here you can see the dendrogram shoppers dataset using the single linkage method, and the same thing was applied in order to get the dendrogram of the shoppers dataset using the ward method. In the same manner, we can specify a specific number of the clusters, 6 in here, to cut the dendrogram horizontally. The scatter plot shows the final data distribution when 6 clusters are generated. Here we have again used this agglomerative clustering. The number of the clusters is set to be 6, and we have also used fit predict in order to find the labels of the classes and clusters. You can see the scatter plot of the data after the hierarchical clustering. You can see that we have 6 different clusters here. Now you can easily perform hierarchical clustering using Python libraries.